Dear students, in the series of numerical physics, we have another numerical which is MCQ also. Means MCQs and numericals both you can take it. It is based on the electrostatics. Now, if we go through the numerical, a charge Q is broken into two parts, Q1 and Q2, and are placed at a distance from each other. What is the magnitude of the charge if these charges exerts maximum force of repulsion? Now, it is a question based on the electrostatics. Force of repulsion means we know the Coulomb's law. F k times Q1 Q2 upon R square. Okay. Now, these two charges which we have got from this means Q will be equal to Q1 plus Q2, and both the charges will be of the same nature, so there will be force of repulsion. Like charges repel each other, whereas unlike charges attracts each other. So here we have got the Q is equal to Q1 plus Q2. Now suppose if we take this as a Q1 and this as a Q2 and separated by distance r, then according to Coulomb's law, we will have K is equals to this Q1 Q2 upon R square. Okay. Now this is a force of repulsion, and if we take this in terms of Q1, then it will be Q2, say Q2. It is Q minus Q1. So we can subtract it with this. So it will be in terms of only Q minus Q1 upon R square. Why we did like this? Because if you want to know the maximum force, you have to differentiate it with the charge and equate it equal to 0. So you will get the maximum force for the condition for maximum force. So here for the maximum force we have this dF upon dQ1. If you differentiate it with respect to Q1 and make it equal to 0, so the condition will come to understand that the maximum force which will be exerted by these charges will have how much magnitude. So here dF by dQ1, it is, we can write it. We can take this K upon R square, both are constant, and d upon dQ1, it is Q into Q1 minus Q1 square. Now we are differentiating it, we are putting it at equal to 0, K upon R square as it is. Differentiation of this will give only Q minus, differentiation of this will give the 2 Q1. Here differentiation of this Q into Q1 will be only Q, and here minus 2 Q1. Now all other values will be 0, so finally we have 0 is equal to Q minus 2 Q1. So here Q is equal to, we have 2 Q1. So Q1 will be equal to Q upon 2. So we have got Q1 equals to Q by 2. Similarly, we can determine Q2. So Q2 will be given by Q minus Q1 means Q minus Q by 2. It is Q by 2 only. Means both the charges of same magnitude, Q by 2 and Q by 2, and same polarity. So there will be the maximum force of repulsion between them if they are placed between at a distance placed between this or at a distance of r. So finally, if we go through the options, here we have Q1 is equal to Q upon 2 and Q2 is equal to Q upon 2. So C will be the correct answer. So this way we can go through such MCQs. Here simply if we go through the another one, distance may be changed or magnitude may be reduced. Sorry. So this way we can go with the numericals.